We're working on understanding typecasting variables. And this idea is in page 32 of your textbook. And typecasting is really made up of two different base words. So we have type and we have casting. So if you cast something, you mold it or shape it into something. And then the type is the style that it's in existing. So in this example, we have some water and we're trying to cast it into a shape of Lego brick shape. And so it's going to take it from its liquid form, and if we put it in this mold and then we freeze it, then it's going to be cast into something different. So in terms of the Java programming language, when you typecast a variable, you take its existing type and you cast or shape it into another type. So far we are aware of three different variable types. And this is a review, but we have string variables, which are text, so the alphabet. And you can also put numbers into a string format, but if you do, you can't calculate on them. It's just like the alphabet. You can't calculate on the alphabet. So if it's in the string type, you have to know that. And strings have to appear between quotes. So if I was doing a variable and it was called name, I could set it equal to my name and I'd have it in quotes and then I end it in the semicolon. And that's how you do strings. When we're talking about typecasting, we're concerned right now with going from an integer to a double or from a double to an integer. So the difference between the two. So integers are whole numbers. And so it's, it could be a negative number, it could be a positive number, but it's just a whole number, so it can't be a decimal. Again, it can be positive or negative. So an example is int num candy is equal to 3. So if I had this variable, I could only have a whole number here. A double is numbers with decimals or fractions. And so you can see we have a negative 0.33. We have 3/4 here, or 19.75. So any of these, if you're dealing with any of these types of numbers, you would put it as a double. And doubles can also be positive or negative. And they call these floating point, and that's just because the decimal point floats. So it could be, right here, there's 2 digits to the left and then 2 digits to the right of the decimal point. Here, there's 2 digits to the right, but there's nothing to the left. So it just depends. The decimal point will float or change, whereas in a whole number, the decimal point's here on the -3. It's here on the 1, and it's here in the same spot on the 200. So it's right between the tens and the tenths. We don't see any of those when we're dealing with integers in our program, but we know that it's there. So this is an example. If you did a double and I had a variable called price, it would be equal to 0.89. So that's the difference between the 3 types of variables. Now when we typecast, we take the existing type of it and we cast it into a desired type. So this is an example of starting off as an integer. So we have a variable called num, and it's equal to 3. And then we're going to cast it into a double. And so the way we do that is we would put in parentheses what we want it to be. So we want it to be a double. And so we put that in parentheses, and then we have the name of the variable. And then this would be the output. So it would now be a double, and it would look like 3.0. So you can do it the opposite way as well. So you can take it from a double and you can cast it into an integer if you want. So the existing type of a double and casting it into an integer. The difference here is that, or what you should be aware of, is that typecasting rounds down. So whatever the number is, it's going to round down. So if I had 3.9, if that was my double, if I cast it into an integer, if I did that typecasting, it would be 3. So in this example, math.pi is going to get cast over as an integer. So you put int in parentheses and then math.pi, and that would turn it into 3. So just to review about the operators, because sometimes when you're doing this, you're also doing some mathematical operations. And so you can do simple computations with these, and you can have a variable name, or you can have an actual number in there, and you can do addition, subtraction, multiplication, or division, and it follows the order of operations, which is PEMDAS. And again, this works only on integers and numbers, so if you're trying to do this on a string variable, it's not going to work. And just to review PEMDAS, so it tells the order in which you do calculations. So you have to always start with the parentheses in your equation. And then after parentheses, you look to the exponents. And after the exponents, you do multiplication and division. These are in the same, they sort of have like the same level. So it depends whichever one comes first. So you're moving always from left to right, just like we read. And so if you come across a multiplication first, then you're going to do that. If you come across division first, you'll do that first. So it doesn't matter. Any of these have the same weight. So from left to right, you're doing multiplication and division. And then the final thing you do is addition and subtraction. And just like multiplication and division, they have the same weight. So whatever one comes first, so even though, PEMDAS, the order says, A and then S, that's not this exact order. These are equally weighted. So if there's a subtraction problem first, you're going to subtract before you add. So that's PEMDAS, which is very important to keep in mind when you are writing equations in Java. I'm in NetBeans and I learned a little bit about typecasting, so now I want to test it out and see how it really works. So one of the things that I'm going to test for is just what does the double look like without typecasting. So I have something called no typecasting, and I'm using the pi, math.pi, because I know that I'm going to get a floating point variable or a number that's going to have a decimal point that won't necessarily be between the ones and the tens position. So for example, in an integer, this is really like we would consider 5.0. It doesn't include the point here because it's an integer, but we know that 5 can be also written as 5.0 in our traditional math language, but in Java, we have integers that just have a whole number without any decimals at all, or we have doubles that have a decimal place that could be in any position, which is why it's called floating point variables. And we use double for that. So this one is using the typecast on this number. So instead of using circumference as a double, I switched it to circumference 2 because I want to have a different variable here. And you can see that I did the typecasting. So I said, okay, I want this math pi, which is normally a double because it has floating point, and I want to change it into an integer. So you put what you want it to be in parentheses. So you can switch from integers to doubles using the same method, but instead inside you would have double. But I want this to be an integer, so what I want it to be, I put in parentheses. And it sort of like just multiplies by that. It switches it. And so what we learned about typecasting is it does it right away. So math pi is converted to an integer before the rest of this equation goes through. So before the calculation happens, this is turned from 3.14 to just plain 3. And down here, I tried to manipulate a little bit. I wanted this calculation to happen before it gets turned into an integer. So I used parentheses because I'm thinking about PEMDAS. And I know order of operations, parentheses go first. So I want them to do what's inside the parentheses first before it multiplies it by here. And that's why in this example, the typecasting happens first because this is in parentheses. So I'm going to hit to compile and run. And you can see with no typecasting, we have all these decimal places. With typecasting, it's 30. And when I think about PEMDAS, it turns into 31. So I'm going to show you using a calculator what's happening. So in the first example, I have pi, and I multiply pi times 2. And I multiply that by the radius, and I set the radius equal to 5 over here. So I'm going to put 5. And I got 31.415926. 31.415926. So I got the exact same number. So that's exactly what I expected. Sometimes I test because when you're running a program, you want to test to make sure you're getting the expected results. So now down here, I have it so that it's going to change it to the integer first. So I'm going to hit clear on this calculator, and I'm going to put pi up here just so you can see what it was like before. And we know when you typecast, it just always rounds down. So even if, let's say this number was 3.7, it wouldn't matter. It would turn this number into 3. So I'm going to just clear this, and I'm going to do the calculation based upon 3. So if I do 3 times 2 times 5, I get 30, which is exactly what's here. And now I'm going to try it again by doing my calculation inside. So if I first do pi, and then I multiply it by 2, and then I multiply that by the radius, which was 5. This is my number. And then if I round down, I'm just going to have 31, which is exactly what prints out there. So it's really important that you understand what happens when you typecast, because it could change what you're getting for results. And that's why you should try and test concepts as you learn new things so you can see.